Would you like to learn about inference engines in generative AI architecture? If so, this video is for you. Hi, my name is Mike Gibbs, and I'm the founder and CEO of GoCloud Careers. I'm joined by David Linthicum, who is an expert in the world of cloud computing and artificial intelligence. And today we're going to talk about generative AI architecture, specifically inference engines. David, before we begin, would you like to say a few words or say hello?
Yeah, I'm excited to be here, Mike, and especially excited to talk about aspects of generative AI. Inference engines are a leg of the stool and how generative AI systems work. Data is the other leg, output's the other leg. The ability to make sense of the logic within these within the knowledge models that are built is very process intensive stuff, and I think it's very appropriate that we're talking about it here today.
Sounds great. And obviously, inference engines are critical to generative AI architecture. Could you begin by telling us what are inference engines, maybe how do they work and why do we need them? And then we can talk more a little bit later about them.
Sure. Well, they're a component of AI systems, machine learning, and generative AI is an aspect of machine learning, as well as deep learning systems, things like that. They're responsible for drawing the conclusions from the facts or rules that are within the knowledge model, in this case, the LLM. And they're able to break down things such as functionality, rules-based reasoning. They're able to do, functions like forward and backward training. They're able to do usage using the applications for different diagnostic systems, things like that. Basically, it's simply put, it's the engine that goes through the knowledge model to determine how to respond to your question that you're asking the knowledge model. So everybody goes to ChatGPT and they'll type in, write a thank you note for me that's, very sincere to my grandmother. And that's an actually true application from it. So when you put that into the system, it goes into the inference engine. The inference engine actually assembles the results for you, or the response for you. The great thing about generative AI, it's able to, in LLMs in general, they're able to generate that response in any way, shape, or form. They can draw you, they can create a song for you, they can create a note, they can write a book for you, they can write a paper for you on how to write a thank you note. All these sorts of things occur, but it's the heavy lifting that goes on in the back within AI. And normally these things are the most process intensive. So you hear people talking about GPUs and TPUs. Those are things that power the inference engines, which have a tendency to saturate processors. So the reason we use GPUs is because we can do lots of things at the same time. Graphical processor units were designed to split apart and, in essence, do lots of parallel tasks and bring the things back together. They're actually controlled by a CPU in doing that. And inference engines are able to take advantage of that because they're able to do multiple things at the same time and run them in a sequential way. Run them in a parallel way. We're not doing them sequentially. And so our ability to assemble an answer or result from this system is going to be a lot better performance. So if you think about analogy would be, if you think of something, in other words, I'm going to ask you a question and you think of it and you're going through your memories to determine what that answer is. In essence, you're being an inference engine. So any kind of thinking and processing that goes on within the systems, all kinds of AI systems are the same. They all have inference engines. They've had them since I was working with them in the 80s. And the different degrees of sophistication. And the difference between that and generative AI is that generative AI is able to generate them in any kind of format, any kind of a language, any kind of way that we want to see the information. So if you look at generative AI, it's in essence a version of machine learning. And what's different about it is just the usefulness of it, in the fact that we can put it out in any kind of format that's going to be most valuable to us. And so in building these systems, we have to understand that the engine that runs these things is going to be an inference engine that goes to the logical functionality, does the backward chaining, forward chaining, the ability to find where these systems is, make sense of the logic, make sense of these models, or use these models in a way that's going to come up with the appropriate answer.
Yeah, thinking about it that way, I think that explains it to people. Now, working on inference engines, are there any recommended guidelines that you can do in certain cases? Are there certain best practices, for example?
Well, the good news is, as architects, we can leverage generative AI toolkits that will have the inference engines processing for us. So,
Okay.
it'll do it'll do the adversarial networking, the ability to have these things communicate with each other. And the great thing about the technology today is we don't have to fundamentally build them ourselves. And so we're going to build the knowledge model using the training data. The training data is going to be built. We're going to test the models to make sure it's in good working order. It has solid data. It's responding with accurate representations of the information. And the inference engines are the ones that take over. They're the engines that drive the thing. So the nice thing about inference engines in general is we don't have to make them, we don't have to build them. We buy them. We use an open source system to make them happen. And they do fairly generic things, but they're functioning on the data which functions on the model that's built. You got to remember that we take, massive amounts of data, and using unsupervised learning with generative AI, it's able to build the knowledge models, the LLMs, and then the inference engines go through it. The hard part is figuring out the data you want to use and figuring out how to build the LLMs effectively. But the ability to ask questions and go through it, if you do that right, is going to be something that just really a pre-con conclusion that it's going to come up with the right answer, but it's still based on the model. So inference engines, even though they're smart, they only deal with the models that are built based on the data that you provided. And so they execute, they find, they do rationale, they're able to look at patterns and look at logic, but it's still dependent on the quality of the model that you built, and the quality of the model you built is based on the data. So I never really get to a point where I'm designing a generative AI system where I'm architecting a system where I'm concerned about the inference engines failing, because they're not normally going to fail. They may perform poorly because of processor things like that, but they're going to be wholly dependent on my ability to build an accurate model, which is wholly dependent on my ability to use the right data. So they execute things, but the thing is, if you architect the thing correctly, you basically have the right ideas and the concepts. The use of an inference engine is going to be a foregone conclusion. That's going to be hard. That's going to be the easiest part of the equation to occur. Now, picking an engine, picking the right toolkits, picking the right design fragments and the architectural patterns to do it is going to be on the table as well. But the great architects will say they need these sorts of inference engine, these sorts of classes, and then we have the AI engineers that will come along and pick the right inference engines. So we know what an inference engine does. We know how to architect a system so the inference engine is going to be successful. But you're setting the engineers up for success because they're the ones who come in, pick the technology, make it work, and get into the details of it. And that's kind of a 1-2 punch. Your ability to, that's why architects design buildings, and then we have steel workers that get in there and show you how to run the steel to build the things. Yes. So with duality of roles, things like that, this is kind of a it's a great thing. It's the synergy of it's awesome. So, keep in mind that the design and someone having an architectural understanding and the ability to kind of layer it into the business is going to be an extremely important role, and other components come in and how you build it. So great thing about looking at the architect, we need to have the architecture things to get the things done in concept, and then we turn it over to the engineers that actually build it with an instance of technology. And I think that's a beautiful thing. That's normally how things are done, and gets it right the first time.
Yeah, and I want to highlight that, and then after that, I want to talk about those adversarial systems, because when I first heard about that was fascinating. But I really want to highlight that architect is there solving business problems. We're not there coding it. We're not configuring it. We're not hands-on. We're working with the executives to find the goals for their business. We're learning their business processes. We're managing stakeholders. We're managing vendors. We're orchestrating teams. We're not actually doing the work. And we're needed to figure out the right design for the business, and we critically need those engineers to go build these systems, because they're the ones that are going to be the deep techies, and they're going to be the builders. That's your experience too, is right?
Yeah, the ability to be a good architect, your ability to orchestrate. So think of it as a conductor in an orchestra. I think that's probably the best analogy I can come up with. So the reason orchestras work well together is because they have a single point that's directing the communications, directing the sequencing, directing how things are designed, and picking the right people. So they're not playing a musical instrument. However, they're probably the most important part of the orchestra because they're coordinating all these things together to get them working together to create beautiful music. And architecture teams are really kind of no different. So we have the orchestration that's done through the conductor. They're bringing all the talents together. They're bringing all the skill sets together, and they're providing the links to the business. They're able to translate the business requirements into an architecture. So everybody understands what their roles and how they play and how the data scientists operate with the AI engineers and your database specialist and your AI ethicist, your ability to have all these different roles that play well together. So in getting to the end state, your job is to see that through, but your job is not to get too far in the detail. If you do, you failed because
Yeah.
you're not going to be able to be, as good at selecting, building, deploying inference engines as an AI engineer is, because that's their role and
No
that's
way.
your job. But you will be able to tell them what kind of style, what kind of type, what that we need, and your ability to have architectural controls, how these things work together with other systems, so we can push the technology and the talent into the places they need to be to generate something that's going to be a great end state. If you don't do that and people get too far in the weeds, it's not going to happen. One of the most common mistakes I see from architects is that they have a tendency to want to get too deep in technology. And normally is something that they know. They may have come from the development background, database background, security background, whatever. And I do notice on their teams, and I have to correct people all the time, they want to get into the weeds on whatever particular technology they're going into. And I understand why, because they feel they can provide some benefits, some value, some assets to make it happen. You're not going to make the overall project succeed by doing that, because in doing so you're going to move the resource, which is you as the architect, into a functional space and not able to see the other spaces, and not able to see the macro problem and understand how things are kind of fit and played well together. So your ability to have a complete understanding that goes with a variety of different technologies and talents is really going to be lead to your success as an architect. It's not going to be your ability to explain to me the differences between adversarial models, things like that with a generative AI system, and how they work with Google versus AWS. You've lost the game if you're doing that. If you're at that level of detail, you don't know the architecture. You're not focusing on the business. You're focusing on the particular technology. And if you're doing that, you're not doing your job as an architect. So I can't stress that enough. So even though we know what inference engines do, we know the core functionality of it, we know the role that they play in the architect, you're not going to get in there and tinker with those. And so that's the role of an architect. That's what you accept as your responsibility. And that's the job that you play.
Yeah. And then, I like to show, I've got a photo. I've got two photos, actually. It all comes over the same photo. In one case, you can see a little squirrel in my backyard, and the squirrel looks beautiful. You can see the grass and the trees. And then I like to take the architect's view, where you can actually see my cat that's actually looking at that squirrel very intently with ill intentions. But you can't see that if you're focused on the squirrel itself. So let's talk about the last thing, adversarial systems. When I first heard that, that was fascinating to me. So maybe you can enlighten the group on adversarial systems.
Yeah, when you build the models, they in essence check each other by the fact that they have. Let me make a better analogy. We have an adversarial system as far as our legal world. So in other
Yes.
words, we have lawyers who take on different roles, and they take on different prospects and arguing the case on behalf of their clients. Well, generative AI systems have much the same, the ability to look at information as it comes in there and make sure that we're coming to separate conclusions, that the conclusions actually agree on each other and they're checking each other. So it's almost like an ongoing argument that's going on. So in other words, I'm looking across at an adversary, which is interpreting information, interpreting data, interpreting the models, and it's making certain calls and certain decisions, and it needs to match what mine is. And if it doesn't, then we have to come to an agreement as to who's right and who's wrong based on looking at additional information. So it's the beauty of AI systems in general, and generative AI specifically, is that we have the ability to, in essence, drive through logic, drive through data, and double check everything that we're doing. So we can relatively assure that we're coming up with the right answers. And so that's why with the exception of a few use hallucinations you get every once in a while. If you use clean data to build these to train these systems, chances are that the outputs and conclusions it comes to is going to be solid. It's going to be valid. It's going to be correct because of these adversarial networks that work in there. And so, that's kind of a core component of generative AI. It's always mentioned with the difference in the system. Again, the beauty of it is we're not going to tinker with that stuff specifically. We know it's there and we know the function and the role that it has. But at the end of the day, this is about getting to what really matters in building these systems. Your ability to select the right logical tools, your ability to select the right data, your ability to select the right logical models, your ability to build these systems from a logical design perspective, conceptual design perspective, your ability to figure out how you're going to train these things best, how you're going to check the models, how you're going to test the models, and how you're going to deploy the models, all these sorts of things. Those mechanisms are important. But the great thing about where we exist in the continuum of technology now, we know they're there. But we don't have to tinker with them. Other people, the engineers, tinker with them. But it's good that it's there because we can explain to stakeholders, we can explain to other team members as to what the function is and what the role is and how that thing kind of comes together. And I think that's the great thing about being an architect. And the role of the architect, again, is to ensure that something is in a good testing state, conceptually correct, it's aligned to the business, and we've selected the right technology to make it happen. So we're not getting in the weeds, doing that for a good reason, because we lose sight of the business if we do that. We represent the business. We're representing a technology configuration that best represents the business. So it could be any number of things that we're going to leverage. And sometimes when you're building a generative AI system, you may find that the AI system may be the second tier solution because it's overkill for some of the stuff that we're working on now. So even that has generative AI systems in it, we're using small language models instead of large language models, and it's taking more of a subordinate role to some sort of a bigger environment. So having that architecture of forethought, your ability not to show up and always build something that's going to be the same everything, that's a problem with people that are specialists in particular cloud providers. In other words, everything shows up, it looks like that cloud provider is going to be the right solution for them, and that drives me nuts. But your ability to have an open mind and an opinion to really kind of ask the questions as to what we're building stuff with the right technology, leveraging it in the correct way. All these sorts of things kind of come to the role of the architect, and we need these people that have these open minds. I don't know how many times I've walked into, lots of times actually, I walked into a client and they're looking to build a generative AI system, and always it's a red flag in my opinion because they've already come to the conclusion that they think they need this. But it's the role of the architect to and sometimes tell them that, there's going to be some AI capabilities here, but that's going to be integrated with the business analytics capabilities because that's primarily what you're looking to build. That's primarily how we're going to address the issue. Generative AI or AI in general is going to be more expensive, and it's going to have a subordinate role in this particular system. So that's what's going to best approach the business, and are able to take the business requirements, look at the architectural configuration that's going to bring the most value back to the business. Guess what? That's not always going to be generative AI forward. And I think that's okay. In fact, if someone tells me that we don't think generative AI is going to be a fit, I'm going to give them a hug because they just, saved me 10 times the amount to build these systems. And it's not always going to be a fit. So it's having a complete open mind and all this stuff, the ability to integrate these various environments, having a complete visibility across different architectural planes within the enterprise. And the big thing is having a good mind of the business. Be a representative of the business, not a representative of technology. You're not there to make AWS rich, Google rich, Microsoft rich. You're there to represent the best interest of the stakeholders, the business that employed you as a consultant or you're employed with, and that's your job. And it's never going to be an advocate or shilling for particular technologies. Maybe not shilling, but not going to and focusing on particular technologies. You do that, by the way, working for me, I'm going to be really concerned real quick where you're going to hear about it. In other words, you're bringing up technology solutions way too early. You're not looking at the bigger problem. And if you're not doing that, you're not playing the role of an architect. And I'm either going to have you do that, or I'm going to have to get somebody else in here to do that for you.
Yeah, and that's really important. What is the customer's goals? About 26, 27 years ago, patients used to come to my office and say, "I need this medication, Mike." And I'd say, "Why?" I saw an ad. I'm like, okay, let's talk about the health challenges you are, what you have. It's the same thing in architecture. When someone calls me in and say, we need to modernize or do this, and I say, great, what's your goals? And so, scarily enough, some of them say, what do you mean? I say, what's the business goal? What are you trying to leverage this technology for? And sometimes they don't know. And those are the companies where they're going to have disastrous technology projects because they just picked the tech and figured they need it. When I walk in and they say, we'd like to create a generative AI system, and I say, why? And they've got all the good business reasons why, I get very happy, because then I know we're going to make a successful architecture which is going to help that business, and they're going to want to call me back again and call my team back again, which is exactly the goal we want long-term: good, strong relationships and very satisfied customers.
Yeah, absolutely. And it's it's good to have a very objective view of this stuff, and not necessarily get into particular technologies. I find that very helpful in your ability to kind of see the forest through the trees, because I think that people have a tendency, and we talked about this a ton, but it bears repeating. They get too enamored and too down in the details with the technology, and they end up missing the larger opportunities to solve the problem. In fact, that's the majority of architectures that I run into. They're driven by a particular technology, maybe a cloud provider or a database provider, something like that. They're not driven by the business. And while you may get, again, to an end state that works, I always hate that word, it's going to be highly inefficient, under optimized for what you're looking to do. So generative AI is going to be no different. In fact, the biggest problem I see with generative AI is you can do a lot of damage fairly quickly by not picking the right technological path, the right architecture. And so you got to have the architectures in charge to make sure you're representing the business. I can't stress that enough. We just don't have enough of that out there. We need more architects that are able to represent the business, able to build these very efficient systems, which ultimately are going to make or break some of these bigger businesses out there.
Yeah, but what exciting times generative AI is for us. David, thank you so much for sharing your expertise with our audience. If you'd like to learn more about generative AI architectures, or how to become a generative AI architect, or a cloud architect, or an enterprise architect for that matter, we've got some free webinars and some free documents to assist you in your career in the description of this video. We also have training programs to help you become a cloud architect, or an enterprise architect, or a security architect, or a generative AI architect. And we love getting people hired. If you've enjoyed this video, please give it a like. Please subscribe to the channel and hit the bell to be notified of new videos to help you in your cloud computing career. This is Mike Gibbs signing off for now. And David, thank you so much.
Thank you, Mike.